Section 1.3, example 20. So evaluating an integral with the fundamental theorem of calculus. So use the fundamental theorem of calculus part 2 to evaluate this integral. So much fun. All right, so part 2, let's just restate it here. So part 2, we have the integral from a to b of f of x dx. This is equal to the antiderivative evaluated at b minus the antiderivative evaluated at a over the integral from b to a. Yep, there we go. So this is actually going to be so much fun. This is where I'm going to consider Calc 2 to actually start. So we start integrating everything. So Calc 1, differentiate everything. Calc 2, integrate everything. All right, let's get started. So just so we have like sight on the whole page, kind of. Let's get this. So the integral from -2 up to 2 of t squared minus 4 dt. All right, so remember antiderivatives. So here we just have that power rule. So when we differentiate, when we take the derivative, we subtract our exponent. So when we do the antiderivative, we're doing the opposite. So we're adding 1 to the exponent. So t cubed. And in order for us to get back to that t squared, we have to do 1/3. So we take the derivative, 3 times 1/3 is going to give us 1, which gets us right back to where we needed to be. And integrating a constant or anti-differentiating a constant is just going to throw an extra variable there. So for t, this whole thing here, we're integrating from -2 to 2. So starting with that -2, we're going to evaluate the function, or we're going to evaluate that middle part here. You can't see him. So we're going to evaluate this here at 2. Evaluating that part there at 2. Let's put it in brackets. 1/3 t is now going to be 2. So 2 cubed minus 4 times t, which is 2. And we have that part. So what we just did was this right here. So now we're going to subtract. So minus. And now we're going to do f of a. So f of -2. So -2, we have 1/3 -2 cubed minus 4 times that -2. And now that we have that, let's find those values. 1/3 times 8 minus 8 minus a -8/3 minus plus 8. So that's going to be 8/3 minus 8 plus 8/3 minus 8. So 16/3 minus 16, which ends up being, let's see, where are we? -32/3. There we go. That's our value right there. That's the value of that integral. So perfect. If you have any questions, please feel free to ask. Otherwise, bye.